Today, we will explore the critical topics of climate change science and its widespread impacts across our planet. Our journey begins with a foundational understanding of how our Earth's complex systems interact and respond to change. Let us now delve into how climate models function, offering us a glimpse into future climate scenarios. These models are built upon fundamental physical laws like those governing fluid dynamics and thermodynamics. They require extensive data input, including historical climate records and greenhouse gas concentrations, to operate effectively. Through complex computations, these models run various simulations based on different emission scenarios. Ultimately, these simulations provide us with valuable projections, helping us anticipate future climate trends and changes. Let us now explore the different types of climate models used by scientists to understand and predict Earth's climate. We will examine how each model varies in its focus and level of complexity to achieve different prediction goals. First, we have energy balance models, which are the simplest type of climate model available for study. These models are primarily used for making very basic and fundamental predictions about the global climate system. They work by balancing the incoming solar radiation with the outgoing heat energy from our planet. Next, we encountered general circulation models, which are significantly more intricate and widely applied today. Indeed, these are the most complex and frequently utilized models for comprehensive climate analysis and forecasting. They are designed to simulate the complex interactions between the atmosphere, oceans, and land surface in detail. Moving on, regional climate models offer more localized and specific climate predictions for particular areas. These models provide very detailed and granular predictions, focusing on the climate characteristics of specific geographical regions. They are especially useful for studying local weather patterns and understanding extreme weather events in depth. Finally, we have Earth system models, which are the most advanced and holistic type of climate model. These highly advanced models incorporate crucial biogeochemical cycles, providing a more complete picture of Earth's systems. They simulate how forests, oceans, and even human activities collectively influence the overall climate system. Let us consider climate projections from IPCC scenarios, which outline different possible futures. These scenarios are based on varying levels of greenhouse gas emissions shaping our planet's destiny. RCP 2.6 represents a low emission scenario aiming for significant reduction efforts. Under this scenario, carbon dioxide concentrations are projected to be around 420 parts per million by 2100. This low emissions pathway predicts a global warming of approximately 1.5 degrees Celsius. RCP 4.5 outlines a medium emission scenario, suggesting moderate efforts to reduce greenhouse gases. Here, carbon dioxide concentrations are estimated to reach about 540 parts per million by 2100. This medium emissions pathway anticipates a global temperature increase of roughly 2.4 degrees Celsius. RCP 6.0 describes a moderate emissions future, implying some action but not aggressive reduction. Carbon dioxide levels could rise to around 670 parts per million by 2100 in this scenario. This moderate pathway forecasts a global warming of approximately 3.0 degrees Celsius. Finally, RCP 8.5 represents a high emission scenario where current trends continue largely unchecked. Carbon dioxide concentrations could soar to about 900 parts per million by 2100. This high emissions pathway projects a significant global warming of approximately 4.3 degrees Celsius. We will now explore the core evidence of climate change, confirming our planet is undeniably warming. Scientific observations collected over decades provide robust confirmation of these profound global shifts. One key piece of evidence is the persistent global temperature rise observed across the planet. Earth's average temperature has been steadily increasing over time, a trend well documented by scientists. Another crucial indicator is the alarming and continuous rise in global sea levels. Ocean levels are increasing significantly, primarily due to melting ice and thermal expansion of water. We are also witnessing a clear increase in extreme weather events worldwide. These events are characterized by their increased frequency and intensity across various regions globally. Let us now elaborate on the global temperature rise, a cornerstone of climate change evidence. Earth's average temperature has notably increased by about 1.2 degrees Celsius since 1880. In fact, The last 8 years, from 2015 to 2023, have been the warmest on record. The atmospheric CO2 concentration now consistently exceeds 415 parts per million, a significant increase. The primary causes include greenhouse gas emissions, widespread deforestation, and extensive fossil fuel use. Impacts range from more frequent heat waves and glacier melt to significant biodiversity loss. We will now focus on extreme weather events, which climate change is making stronger and more frequent. These events represent a significant and growing threat, fueling more intense disasters globally. Hurricanes and cyclones are becoming increasingly powerful, posing greater risks to coastal communities. Warmer oceans provide more energy, fueling the development of stronger and much better storms. Consequently, we are observing more frequent occurrences of Category 5 intensity storms. Heat waves and wildfires are also increasing in frequency and severity across many regions. Longer, hotter summers create ideal conditions, leading to more frequent and devastating wildfires. Indeed, record-breaking wildfires have been observed globally, impacting vast areas and ecosystems. Flooding and heavy rainfall events are becoming more common and intense as well. Warmer air can hold more moisture, which then leads to significantly heavier rainfall. As a result, flash floods have become a much more common and destructive phenomenon. Finally, droughts and desertification are worsening in many parts of the world. Reduced rainfall combined with higher temperatures leads to severe water shortages globally. This directly affects agriculture, threatens food security, and impacts essential water supplies. Now, let us examine the profound impacts of climate change on Earth's diverse ecosystems. Climate change severely disrupts natural habitats and marine life, threatening their delicate balance. One major consequence is significant biodiversity loss, affecting countless species globally. Species are declining or facing extinction due to rapid temperature changes and widespread habitat loss. We are also witnessing extensive habitat destruction across various natural environments. Natural environments are being damaged or lost from melting ice, devastating wildfires, and increasing desertification. A critical issue in marine environments is the ongoing problem of ocean acidification. Oceans absorb CO2, forming carbonic acid, which reduces ocean pH levels. Let us now discuss the critical issues of rising sea levels and increasing water scarcity. Global sea levels have risen by approximately 20 centimeters since the year 1900. The melting of glacial and polar ice caps contributes significantly to this ongoing sea level rise. Additionally, the thermal expansion of warming oceans causes an increase in overall ocean volume. Water scarcity is worsening globally due to unpredictable rainfall patterns and prolonged droughts. Moreover, saltwater intrusion contaminates vital coastal freshwater sources, impacting drinking water and agriculture. We will now explore the impacts of climate change on human health, migration, and livelihoods. These are crucial societal impacts that arise from our continuously changing climate. Health risks are increasing as global temperatures continue to rise unchecked. Specifically, heat-related illnesses are on the rise, impacting vulnerable populations worldwide. Furthermore, infectious diseases are spreading faster, adapting to new environmental conditions. Climate migration is becoming a significant global issue, displacing millions of people. Millions are being displaced from their homes due to climate-related disasters and environmental changes. This often leads to urban overcrowding and contributes to growing refugee crises globally. Finally, climate change has substantial negative impacts on various livelihoods. There are widespread job losses occurring in key economic sectors like agriculture and fishing. This ultimately leads to increased poverty and greater instability within affected communities. To conclude, let us summarize the key takeaways that are important to remember from our discussion. These are the essential points that you should carry forward from this lecture. Climate models are absolutely vital for predicting future climate risks and guiding effective policy decisions. Earth is experiencing significant global temperature rise, sea level changes, and more extreme weather events. Ecosystems face severe threats, including biodiversity loss, habitat destruction, and critical ocean acidification. Human societies confront major challenges in food security, water resources, health, and sustainable livelihoods. Urgent global action is necessary to mitigate climate change and adapt effectively to its far-reaching impacts.